Assalamualaikum and good evening. My name is Siti Nur Atira. This is the Prelab for part 1. The address for main switch is 10.02 and the address for emergency switch is 10.03. This switch will control the whole operation. The motor address is 100.00 and the standby light is 100.01. The start button address is 10.00. The stop button address is 10.01 and the timer T000. The timer is set for 5 seconds.
So I will continue with the CX designer for this task 1. Okay, now I will explain the movement of this program. When we push the pen switch button, the standby light will light up and the whole operation will turn on. Then when we start, we push the start button, the motor will turn on until 5 seconds. And then it will stop and standby light will turn on. Next, if we push the start button and stop, the motor will immediately stop. But the start button can operate it again if we push the start button. So if we push the start button and we push the emergency switch, it will be the start button will be not working to turn on the motor and the standby light will turn off because we have pushed the emergency button. So if we want to operate it again, we have to turn on the main switch and we can start it again for 5 seconds.
Hi, my name is Musfira binti Mota. I will explain for task 2 Prelab 2. So the first one is PB button start. The address is 10.00. For PB button stop, push button stop 10.01. Working bit for the operation is W0.00. The output for box conveyor is 100.00. The output for Apple conveyor is 100.01. For the sensor ones, box sensor is 0.01. Sensor 2 is Apple sensor 0.02. This is the counter to count 10 Apple. For the counter is C010 and working bit still 0.1, 0.00. Sensor Apple is 0.02 and the box conveyor is 100.00.
This is the task 2 PLC HMI programming for an Apple packaging system for the CS design. We will start by pressing the start button to start the operation. As you can see, when start button is pressed, the box conveyor will run until the sensor to detect the presence of the box. We will press the sensor 2 to activate the sensor. The box conveyor will stop operating and apple conveyor will run. Sensor 1 starts to detect and count for 10 apples. So we need to press the sensor 1 about 10 times. And as you can see, the apple conveyor will stop and box conveyor will run again. This is a continuous system until the stop button is pressed. Okay, that is all.
Hi, I'm Mary Magdalene. Now I'm going to talk about the conclusion for this whole task. As for task 1A, we initiated our project by laying the foundation for our Apple packaging system through basic PLC programming with Omron CX programmer. This involves configuring the PLC, the system central control unit, and crafting the logic that governs the operation of components like conveyor belt, sensors, and activators. As for task 1B, then it shifted our focus on the development of the human machine interface, which is HMI, using Omron CX Designer. We designed a user-friendly interface with screens, buttons, displays, and controls, enabling seamless interaction and monitoring for human operators. Task 2 is marked the culmination of our work, where we seamlessly integrated the PLC programming from task 1A with the HMI programming from task 1B for our Apple packaging system. This integration ensures that the PLC executed control logic while the HMI provided an intuitive interface for system oversight. The harmonious interplay between the PLC and HMI resulted in an efficient and user-friendly automation solution. In summary, Task 1A established core control logic. Task 1B designed the user interface, and Task 2 successfully integrated this component and create a fully operational Apple packaging system delivering a coordinated and user-friendly automation solution for our Apple packaging requirements. That's all from me. Thank you.
That's all from us. Thank you.